So this question is actually an exercise from the applications of calculus course, and we're gonna work on it. It says here, right? It's an 8-mark question, like it says the frame of the box indicated in the diagram is made up of 12 plastic rods. Okay, so they're referring to these here. You see, like 1, 2, 3, 4, 5, 6, 7, 8, yep, 8, 9, 10, 11, 12. Whew. Yeah, so they're referring to those plastic rods. But then the idea is, right, with these plastic rods, you actually have sets of what you call, there's one set that is this high. You see, there's 4 of them. You see, so let's color code it and actually make it green. And then there's another set that's this length. So let's make those pink. These are also 4. And the last bunch is this distance. So from here to there. Oh, come on, bro. Come on now. So I think this is important because, I mean, like, if you have these plastic rods here, they say here, it's made up of plastic rods that have a total length of p centimeters. So before we even carry on, we just want to be able to put our information in order. So the p here is technically all our different sides put together. What did I just press? What did I just press? Ish, yeah, it's back now. I need to make this a bit bigger also. So what we need to recognize is that the p here, right, is basically this length here. They say here, before we even read the rest here, they say the width of the box is half the length. Okay, so this is x, right? This is 2x. And then you have height. So technically our p is just 4 multiplied by the height. So we can say 4h there plus 4x plus 4 multiplied by this 2x, you see. So if you do simplify this, you're technically gonna have 4h plus 4x plus 8x, which is technically gonna be 4h plus 12x. So this is what actually p is, right? And then it says if the volume is a maximum, okay, determine the length of the box in terms of p. Okay, this is quite interesting. You're now the length. Okay, they want us to determine the length in terms of p. Yo. Yeah, I see why this is an 8-mark question. Because this question, just by looking at it, like with the few things that we have read, yeah, it's not very straightforward. But this is the one thing you'll always hear me say when it comes to applications of calculus, right? Depending on what they're talking about, you see here they're talking about maximum volume. So the one thing you may want to focus on is getting a volume equation. Get a volume equation, and then the portion where it says maximum there, all it means is what you'll have to do with that volume equation is that you would need to differentiate it and make it equal to 0. Whatever you will be working out after making it equal to 0 is going to be a specific value for your dimensions that will cause the highest volume possible. So in words, it's all just a bit all over the place. So let's just take it slow. We're talking about volume here. So let's see what a volume of this shape would be. The volume of our shape would technically be h times the width times the length, you see, because this is like a, a rectangular prism. So the volume is height times width times the length there. So it's just going to be h multiplied by the x multiplied by the 2x. If you simplify this, you are going to get what you're gonna get. You're technically gonna get h and x, 2x squared. That's the volume. Now the funny thing is they want here to give they want us to give they said if the volume is a maximum, determine the length. So what we can recognize here is the length is affected by the value of x, you see. It says determine the length of the box in terms of p, showing all workings. So if the length needs to be in terms of P, and we're talking about volume, it means that, yeah, looking at our volume equation, right, it looks as though our volume equation is only going to be useful to us if it is at least in terms of P or in terms of X, you see, because at least that incorporates the length there, and then that incorporates the P that they're talking about. So what we can actually do, keeping that in mind, is that this equation here, right, we can actually maybe isolate H, because H looks like it's the weird one. It looks like, let's isolate H here so that we can throw a value of H here. Our equation here will only have like a P and an H. So let us do that. So here, if you're going to isolate H, you're going to have here P minus 12x equal to 4H, right? And then divide by 4 on both sides. You're going to have here divide by 4 here, divide by 4 here. So here you'll technically have P minus 12x over 4. This is what H is. So let's throw this H in this equation. Let us do it. Let us do it. So throwing H into our volume equation, we're going to have P minus 12x, the whole thing over 4. So if the whole thing is over 4, right, you're better off writing this as a bracket. And then, no, let's not complicate things, bro. Let's keep things simple. Let's just put here our P minus the 12x over 4. Then you have brackets there. And then here you're technically going to have 2x squared. You see, so we're putting it over 1 because, I mean, like, it's being multiplied by a fraction. And then I'm looking at this, I'm like, bro, how did you run out of space so easily? Like, bro, come on, bro. Like, yes, like, hey, yeah, should have given myself like a gang load of space for this question, but somebody did not do that. Don't know why. I actually maybe should have just cut out this and then have like worked it out on like something separate. But hey, here we are. So let's maybe simplify our volume equation just a little bit. So simplifying our volume equation, it will be this multiplied by our P there. So it's going to be 2 px squared. Yeah, 2p x squared. And then we can technically put the whole thing over 4, right? And then this, if you multiply it by that, it's going to be like negative 24 x cubed. Whew. Yeah, okay, so this is very weird, but then I think it's best if you put everything over 4 individually, because I think it'll be easier to simplify. So this, we can put it over 4. This, we can put it over 4, you see. And then you will technically have a half px squared minus, what is 24 divided by 4? I think that's a 6, right? So it's going to be 6x cubed v. So this is an equation of volume, right? Now, because they want us to, they said if the volume is a maximum, determine the length of the box in terms of P. Okay, so if we're going to determine the length of the box in terms of P, if the volume is a maximum, the key thing is to remember, if the volume is a maximum, then you may want to work with the first derivative of this equation in terms of x. So if this equation, if you're going to focus on x as the main variable, the first derivative of this equation would be 2 times a half p, which is just going to be p, and then you remove 1 from the exponent. Here, 3 times what you may call 6. I mean, 3 times negative 6 is going to be negative 18, and then you're going to remove 1 from the exponent. It's going to be squared over there. Now, this is your first derivative. Now we said anything to do with maximum, right? All you do is you need to have a first derivative of whatever they're referring to, and then that first derivative, you need to make it equal to a 0, you see. So this equation, you need to equate it to a 0. And then what you're seeing here is we are clearly seeing that we have an equation here in terms of p and x. Now our length is just 2x, you see. So they said here we should what? If the, you see, I keep going back to the question because you really want to be, certain of what are they asking. Is it correct? Does it make sense? If the volume is a maximum, determine the length of the box in terms of P. So we need to get x here so that we can just throw x there and see what the length would need to be. So if you're going to solve for x here, you can clearly just factorize here. You can take out x as a common factor. You're going to have p minus 18x, you see, equal to 0. So here x is equal to 0, which would clearly be like the minimum length, because any equation that is maximum or minimum, you're always going to do the exact same thing. You would need a first derivative and you'd need to equate it to 0. So when you get two answers, one of them will be for what will cause the minimum, for example, this will cause the minimum length, technically speaking. And then the other answer, which is like minus p, which is p minus 18x, this will cause maximum length. So if you solve for p here, for x, you're gonna have 18x go over here, and then your value of x here, you're gonna divide by 18 on both sides, so it's like p over 18. So for you to have, so the length, if you're gonna determine the length in terms of p, right, for where the volume is a maximum, your length is technically going to be 2x, right, which is going to be 2 multiplied by p over 18, which is technically going to be p over 9. Whew, so this is going to be, this is quite an interesting question with an interesting answer. And you can see why it's 8 marks, because it's not child's play, this question, it's the kind of a question that needs you to understand what these keywords mean. You see, if the volume is a maximum, determine the length of the box in terms of P. So what we needed was a volume equation. This volume equation, we needed to have it with at least just a P somewhere and something that can refer to the length, which is just P and X. So once we had a volume in terms of, P and X, what we did was we had to differentiate this equation using X as the main variable, because we're talking about our length. We have to use X as the main variable. So we differentiated this in terms of X. And then, we differentiated this in terms of, X, because P is technically going to be fixed. So we differentiated this in terms of X. And then after differentiating this in terms of X, we are looking for the length that would cause the maximum volume. So we would need to equate it to 0, our first derivative. And then here we solved for X. So we got two answers for X. One of them equal to 0. This would cause the minimum length, but then the other one here would cause the maximum length, see, of which the length is just 2x. So 2 times this value is what's giving us P over 9. Whew. So yeah, you can see this is an exercise from the applications of calculus course. And yeah, within the applications of calculus course, it goes down. It goes all the way down, because the first chapter is specifically going to work on just being able to differentiate properly. And then the follow-up chapters, they just dive into some aggressive looking questions. And you can see some of the activities here, they help you to sharpen your X. And you can see some of these questions here. It's like, what is going on? So you can imagine if you go on the course platform, you can just click in the bio. Actually, you'll go to the course platform, and then you'll be able to sign up, and then you'll have access to all these questions over here. So I highly recommend it. If you need anything, just hit me up, and then I shall help with whatever I can.